Hi, mathletes. Welcome to this week's question of the week. And this problem comes from the Problem Solving Experiences in Mathematics workbook. So this is a figure, and I want you to count how many rhombuses there are. You can pause the video, and then when you're ready, you can resume and see how I solved it. Welcome back. How'd you do? Do you think you counted them all? Well, let's see. I decided to make a table so that I wouldn't miss any of the rhombuses, and I decided to look for a pattern. So here's my table. The first column is the size of the rhombus. Then I'm going to count the number of rhombuses, and then I'll have my total. So for the size of the rhombuses, I noticed that it could be a 1 by 1, a 2 by 2, a 3 by 3, a 4 by 4, or a 5 by 5. Remember that the rhombuses are the same lengths on all sides. Then I'm going to count how many are 1 by 1, 2 by 2, 3 by 3, 4 by 4, and 5 by 5, and then I'll get my total. So starting with the 1 by 1. So a 1 by 1, I notice that there's only one that's 1 by 1. Now let's look at the 2 by 2. So for the 2 by 2, I notice that there's 4 1 by 1s. 1, 2, 3, and 4. And then 2 by 2, there's only one. This is the one right here, so it gives me a total of 4 plus 1, which is 5. Now we're going to look at the 3 by 3. And for the 3 by 3, I notice that there are 9 1 by 1s. There are 4 2 by 2s, and then of course 1 3 by 3, which gives me a total of 14. Now we'll look at the 4 by 4. For the 4 by 4, there's 16 1 by 1s, there's 9 2 by 2s, 4 3 by 3s, and 1 4 by 4, which gives me a total of 30. And for the last one, the whole figure. So the 5 by 5, there are 25 1 by 1s, there are 16 2 by 2s, there are 9 3 by 3s, there are 4 4 by 4s, and then there's just 1 5 by 5. So the total is 55. So there are 55 rhombuses in the figure. Did you notice any patterns? I noticed here that it looks like these are all 1s diagonally, and then we have 4s, and then 9s, 16, and 25. And what makes those numbers special? What do you know about numbers like 25, 16, 9, 4, and 1? Well, I noticed that in that first column, 25 is 5 squared. And then in the second column, 16 is 4 squared. 9 is 3 squared. 4 is 2 squared. And 1 is 1 squared. So it looks like they are the squares of the total numbers. Interesting. Very cool. Okay, are you ready to exercise your brain a bit more? Because we have an extension. Let's look at the same figure, but this time I want you to find parallelograms. So now all the sides don't have to be the same length. Opposite sides need to be. Okay, again, you can pause the video, and then when you're ready, you can resume. Welcome back. Okay, did you make another table like I did, or did you just try to count? What method worked best for you? Well, I decided to make another table and to try and find another pattern. So here's my table. And this time, instead of the 1 by 1 and the 2 by 2, I knew that opposite sides needed to be equal. So I did the width and then the height and then my total. So then I would add it up to get my grand total. So that the width could be 1, 2, 3, 4, 5, but the height could also be 1, 2, 3, 4, 5. Okay, so we'll start with the first one. And I noticed that if it's a 1 by 1, there are 25 of those. A 1 by 2 has 20. A 1 by 3 has 15, a 1 by 4 has 10, and a 1 by 5 has 5, which gives me a total of 75. A 2 by 1, there's 20. A 2 by 2 has 16, a 2 by 3 has 12, a 2 by 4 has 8, and a 2 by 5 has 4, which gives me a total of 60. Then I have my 3 by 1, which is 15, 3 by 2 is 12, 3 by 3 is 9, 3 by 4 is 6, and 3 by 5 is 3, which gives me a total of 45. Then I have a 4 by 1, which is 10. The 4 by 2s, there's 8. 4 by 3 has 6. 4 by 4 has 4. And 4 by 5 has 2, which gives me a total of 30. And for the last row, I have 5 by 1, which is 5. 5 by 2 is 4. 5 by 3 is 3. 5 by 4 is 2. And 5 by 5 is 1. which gives me a total of 15. So my grand total, if I add all these up, is 225. So there's 225 parallelograms. Did you see a pattern here? Well, these aren't perfect squares, but what did you notice? You might want to stop the video here and look at it for a bit, and then when you're ready, you can resume. So here's what I noticed. I looked at that first row and I noticed that all those numbers have a difference of 5. In the second one, they have a difference of 4. In the third row, a difference of 3. The fourth row, a difference of 2. And the last row, a difference of 1. That's going across. But if we look at going up and down or vertically, those also have a difference of 5 for the first, a difference of 4, a difference of 3, a difference of 2, and a difference of 1. So I hope that you like this. It's fun looking at those patterns, isn't it? There's so many different patterns in here that you can see. Pretty cool. I also noticed here diagonally, these are perfect squares, which is pretty cool. Okay, but again, if you look at this table, you're going to see lots of patterns in it. This is just one of the many. So if you enjoyed this video, make sure you subscribe so that you never miss a question of the week. There's new problems every week. And leave a comment below. Maybe you can tell me how hard you thought this was, or if you used a different strategy. And maybe you have a friend who would love this challenge. If so, share it with them. As always, thank you for watching.